To study the relationship between temperature of a body and time by plotting a cooling curve. According to Newton's law of cooling, the rate of cooling of a body is directly proportional to the difference in temperature of the body and its surroundings, provided the difference in temperature is not too large and all other conditions remain the same.
Madam, how can we study the relationship between temperature of a body and time by plotting a cooling curve?
Consider a body whose temperature at any instant t, b, and temperature of its surrounding is then, according to Newton's law of cooling, log theta minus theta 0 is equal to minus kT plus c, where k and c are constants. Let's do an experiment to study the relationship between temperature of a body and time by plotting a cooling curve. Our aim is to study the relationship between temperature of a body and time by plotting a cooling curve. The materials required are Newton's law of cooling apparatus consisting a thin-walled copper calorimeter suspended in a double-walled enclosure with stirrer and a lid, 2 thermometers, clamp and stand, stopwatch, a beaker, a heater. Procedure. First of all, place the Newton's law of cooling apparatus on the table and fill the space between double walls of the enclosure with water which act as surroundings at constant temperature theta 0. Fill the calorimeter 2/3 with hot water having temperature about 80 degrees Celsius. Suspend the calorimeter filled with hot water inside the enclosure along with the stirrer in it. Cover the system with a wooden lid having a hole in its middle. Take 2 thermometers, T1 and T2, and note their least counts. Suspend 2 thermometers from the clamp and stand and insert thermometer T1 in the double-walled enclosure and thermometer T2 in calorimeter water as shown. Note the least count of the stopwatch and set it at 0. Note the temperature of water theta 0 with thermometer T1 in enclosure. Start stirring the water in calorimeter to make it cool uniformly. Start the stopwatch when the thermometer T2 reading is convenient, say 70 degrees Celsius, 60 degrees Celsius, etc., and note the temperature. Note the readings of thermometer T2 after every 1 minute. After 5 readings, increase the time interval between 2 successive readings to 2 minutes. Keep on taking readings of thermometer T2 until temperature of hot water is about 5 degrees Celsius above the room temperature. Now, note the reading of thermometer T1, that is, the temperature of water in double-walled vessel, and find its mean value, theta 2. Record all observations in a tabular form. Least count of thermometer T1 is equal to x degrees Celsius. Least count of thermometer T2 is equal to x degrees Celsius. Least count of stopwatch is equal to x seconds. Observations. Initial temperature of enclosure theta 1 is equal to x degrees Celsius. Final temperature of enclosure theta 2 is equal to x degrees Celsius. Mean temperature of enclosure theta 0 is equal to theta 1 plus theta 2 divided by 2 is equal to x degrees Celsius. Table for calculation of cooling with time. Serial number, time t, minutes, temperature of hot water, theta, degrees Celsius, theta minus theta 0, degrees Celsius, log theta minus theta 0. Result. The temperature falls quickly in the beginning and then slowly the difference of temperature between the body and its surroundings goes on decreasing. This is an agreement with Newton's law of cooling. The graph between log 10, theta minus theta 0 and time t is straight line. Hence, the Newton's law of cooling is verified. Precautions. Double-walled enclosures should be used to maintain surroundings at a constant temperature. If temperature of surroundings changes, then take mean of initial and final temperature of surroundings. The hot water should be stirred continuously and uniformly. The outer surface of calorimeter should be blackened. The lid should be airtight. Sources of error. Surrounding temperature may not be constant. Lid may not be airtight.
Thank you, ma'am, for this knowledgeable experiment.